Welcome to STEM School. We're now doing Unit 2 of A-Level Maths. We're looking at polynomial. Poly means many and nomial means term. Many terms. So what's a term then? Term is ax to the power of n. And the a is what we call coefficient, which is a number in front of the x variable. The x in this case is a base, which is a variable base. And the n is what we call exponent, which is also called power, and it's also called index. So an example of a term in this case will be 3x to the power of 2. The coefficient of x squared is 3 and 2 is the exponent. The exponent is also a number. So I'm going to write a typical polynomial equation. A typical polynomial equation which is y equals, let's start with ax to the power of 4 plus bx to the power of 3. If you notice the coefficient, the exponent is decreasing by 1, plus cx to the power of 2 plus dx to the power of 1 plus ex to the power of 0. So this is a 5-term polynomial. It goes on forever. You can get x to the power of 5, x to the power of 6, x to the power of 7, and it goes on. Just to remind us, x to the power of 1 is also called x, and x to the power of 0 is 1. So now I can write this properly by saying ax to the power of 4 plus bx cubed plus cx squared plus dx plus e, because e times 1 is e. And the highest exponent, the highest exponent, the highest exponent is called degree of polynomial. So the degree of polynomial for this polynomial here function is 4. And so now I'm going to talk about some important facts that we need. First of all, the degree of polynomial, which I coined as DOP, the degree of polynomial tells us three things. It tells us it's also equal to the number of factors in the polynomial. So it's also equal to factors. It's also equal to the roots. And the third thing is the degree of polynomial is equal to turning point plus 1. So if you want to find the turning point, you take away 1 from the degree of polynomial. So which implies that turning point equals degree of polynomial minus 1 for a polynomial function. So these are the three important things. So what is a factor? This is one factor, and this is two factors, and that's three factors. And what's a root? A root or solution is where the curve cuts the x-axis, So where the curve cuts the x-axis, in this case, this polynomial function has 4 roots, because the exponent, the highest exponent is 4. It's got 4 factors, and it's got 3 turning points. So now, let's write some expressions down. Okay, so we start with y equals ax to the power 4 plus bx cubed plus cx squared plus dx plus e. Now we can write down the name. So what we want to do is we want to write down the name of the graph. We also want to write down the dope of the graph, degree of polynomial. We want to write down the factor. How many factors does it have? How many roots does it have? Alpha roots. And turning point, TP, how many turning points? We also want to be able to sketch the graph. So we're going to sketch the graph. So for the first one, the name of this graph, because it's 4, the highest exponent is 4, this graph is called Quartic. And the degree of polynomial is 4. It's got 4 factors. It's got 4 roots and 3 turning point. Turning point is degree of polynomial minus 1. And if the coefficient of the highest exponent, coefficient of highest exponent, if it's positive, just let me first of all talk about that. I'm going to write down the quadrants of a graph. This is the first quadrant. This is the second, third, and fourth. we write from left to right. We also draw graphs from left to right. We only use the third and the fourth, the second and the third quadrant to sketch our graphs. If the exponent is even number, like 4, 2, and the coefficient of the highest exponent, in this case a, is positive, we start our graphs from the second quadrant. If the degree of polynomial is 3 or 1 or odd, and the coefficient of the highest exponent is positive, we start drawing our graphs from third quadrant. Otherwise, it's reverse. So let's have a go. I got my X and Y. Okay, so this is an even exponent, 4. The coefficient here is positive, and we've got 4 roots, which means we're starting from the even function. 1 cuts 1, 2, 3, and 4. So the roots are 1, 2, 3, and 4. And the turning points will be the 1, 2, and 3. That's the turning point. For a negative graph, a negative coefficient of the highest exponent, we start from the third. 1, 2, 3. The roots are 1, 2, 3, 4. And the turning points are 1, 2, 3. So that's how to sketch a quartic graph, which is x to the power 4. If it's x to the power 5, it would be 5 turning point. 5 is odd. It will start from the third quadrant. You have to draw a wave, come back 5 times. So you cut the x-axis 5 times. If it's x to 6, it's even. You start from the second quadrant, and then you draw. It looks like that, but we have to have another go. So now let's do the next graph, which is, just let me put here, negative coefficient. So that will be coefficient of higher exponent is negative. So another graph we could draw is y equals bx cubed plus cx squared plus dx plus e. And this graph is cubic, and it's got the highest exponent is 3. It will have 3 factors, 3 roots, 2 turning points. So let's sketch. So to sketch this, it's an odd exponent. So we start, and the coefficient is positive of the highest exponent is positive. So we start from the third quadrant. 1, 2, 3. So it cuts x-axis 3 times. 1, 2, 3. And the turning point is maximum and minimum. This is minimum, maximum, minimum. Maximum, minimum, maximum. For the coefficient of higher exponent, which is b, if b was negative, that means minus b. Drawing that, we'll start from the even quadrant, so second quadrant. 1, 2, 3. First root, second, and third. Turning points, minimum and maximum. So now let's do the y equals cx squared plus dx plus e. Right. So this function is quadratic. Till I see there. It's got the highest exponent is 2, so it will have 2 degree of polynomial, 2 factors, 2 roots, 1 turning point. So let's sketch. C is positive, the highest exponent coefficient. So we start from the second quadrant because it's even exponent. 1, 2, that's the where it cuts the x-axis, and that's the turning point. When C is negative, we start from the third quadrant, and now we have the where it cuts the x-axis, and maximum is the turning point. Here is a minimum. And then we have y equals dx plus c, and this is linear. One degree of polynomial, 1 factor, 1 root, 0 turning point. So if we were to sketch that, because it's odd exponent and positive coefficient of the highest exponent, we start from the third quadrant. Now to do the negative coefficient of the highest exponent with a odd exponent, we start from the even, from the second quadrant. 1 it cuts the x-axis, 1 root, 1 factor. Now the final one to look at is the constant function. In this case, y equals c. Don't forget that y equals c is y equals e, sorry. y equals e. Don't forget that y equals e is actually e x to the power of 0. This is horizontal constant lines. And the degree of polynomial is 0, no factor, no roots because it never counts the x-axis, and 0 turning point. So if I sketch that, the positive version would be those line, horizontal line. These are horizontal line with no gradient. So the equation for this one, if that was 2 and that was 1, that would be y equals 2 and that would be y equals 1. So that's the positive side. For the negative, in fact, the x-axis is y equals 0. So the x-axis here is y equal to 0. The y-axis, we can talk about that later. But for the negatives, we're drawing the line below 0. So that's minus 1. So that's y equals minus 1. If that was minus 2, that would be y equals minus 2. So that's the constant, y constant. We have another equation which is x constant. So if I have x equal to c, a constant, there are two sides to this. The x constants are vertical. They are vertical constant line. So these are vertical constant line. For the positive vertical constant line, in fact, y-axis is x equal to 0 because this is 0. X equals to 0 here. X equals to 1. X equals to 2. X equals to minus 1. X equals to minus 2. So if I draw a line, a vertical line here, which is infinity gradient, so the gradient here will be infinity because you can't climb it. This is x equals to 2. If I draw another line here, that will be x equals 1. For the negative, if I draw a line there, that would be x equals minus 1. And if I draw another line here, that would be x equals minus 2. So the constant line, there are two of them, which is a vertical line, a vertical constant line, which is x equals to c. We'll have infinity gradient, and the y equals e or c is horizontal constant line. We'll have a 0 gradient.